Hi everyone, thank you for watching my previous session on managing of tables in PostgreSQL database. Today I'm going to cover the topic on managing the rest of the objects like indexes, functions, views, triggers and sequences. Let's move on to indexes. So indexes are special lookup tables that the database search engine can use to speed up of data retrieval. There are different types of indexes in PostgreSQL. The first one is B-tree, which is a default one, which supports multiple operators like equal to, not equal to, greater than or equal to, less than or equal to, and so on. Coming to hash index, which supports only equal operator. Okay. The third one is GAST and SPGAST, which is more suitable for geometric data types. Okay, like if you have a data type called circle, cube, point. Okay, in that case this is the more appropriate index type you can use. The fourth one is GIN, that is inverted indexes. This type is best suitable where you have multiple values in a single column, for example arrays, HStore and JSONB data types. The final one is BRIN, that is nothing but block range indexes. Today in my demo I'm going to cover mostly on B-tree indexes like creation of index, dropping of index and listing of indexes in PostgreSQL database. So before proceeding to my demo, let me show my environment details over here. This is the IP address of my PostgreSQL DB server and this is the port. This is the database which I am going to connect. So this is the user which I am going to use to connect the database. Okay. It's connected. Let me go to the databases. Right click, open query tool. So let me open my demo scripts over here. So this is the table which I'm going to use for my demo, which is holding 500,000 records. Okay. So right now I don't have any indexes. Let me show the table details. Go here. Okay. I don't have any indexes. So before executing this query, let me show the explain plan of that query. Okay, let me drag it over. You can see the details over here. It is going to be sequential scan and the cost is higher. If you can see, execution time is also higher. Okay, so now part of this, let me create one index. Okay, and let us see the explain plan again. So it is doing index scan. You can see index details over here as well, and you can see the expected execution time as well. Okay, let me try to execute the statement without index and let us see how much time it is going to take. You can see the time over here, it's 506 milliseconds, right? Okay, let me show now with index. Created the index, execute the same statement here. It is taking 91 milliseconds. See, one more point you need to remember, like if you are fetching the data, repetitively, like same data, the data will be present in memory for sometimes. That also will adds extra benefit along with indexes. If the data is not present in the memory, it may take little bit more time. Okay, let me move on further. Now there's a little bit change in my query. I'm using two columns over here. Okay, let us see the explain plan of this query. Still it is using same index even though I have couple of columns in my where class. Okay, and the execution time also lesser in milliseconds, right? So what I'm going to do now, I will create a composite index. Okay, let me show the explain plan. Okay, now go to the explain plan of this. So this is using the new index. Postgres is intelligent enough that it knows which index to pick, right? This is more appropriate index which contains couple of columns in my index, whereas this one is having only one column. Okay, but benefit wise we may not see that much difference. Okay, but it is always use appropriate index. Okay, and one more advice, like don't create too many indexes on a specific table, which will degrade the performance of your insert and update operations, where you have batch jobs which loads lots of data into the table. Okay, let me execute this query. Okay, try to execute this query now. Don't create too many indexes. Okay, if you don't see any benefit or much benefit. Now let me list the indexes what are all present over here. Okay, so I have two indexes here on this particular table. The other two are related to other table. Okay, now let me proceed to drop the indexes. Done. Now I don't have any index. For demo sake, let me execute. Right, see how much time it took. Earlier it is less than 100 milliseconds, now it is 476 milliseconds. Now let me move on to my next topic, that is functions. So functions are also known as store procedures, which allows us to carry out operations that would normally take several queries in a single function within the database. So in my demo I'm going to cover like creation of function, dropping of function, and the listing of functions. Okay, let's move to demo. Let me close this index demo to avoid confusion. Select database, go to query tools. Let me load my functions demo scripts over here. Okay, let me drag this down. Okay, so part of this, what I'm going to do here, I'm going to create a table here. Okay, and I will insert couple of rows or records, sorry. Okay, let me show that. Okay, table created, first row, second row. If I fetch the data, I don't have results over, right? So for that I just written one small function which will update my results column based on the criterias. Okay, so it's a pretty simple function where I'm doing like validation of my marks. If it is above 35, I am saying the result as pass. Okay, similarly if it is less than that, then it will come under, it will be stated as fail. Okay, let me create the function. Good. If you come over here and if you see, it will be listed over because I created, right? That is the reason why this particular function is over here. Okay, now I'm calling my function to update my table. Okay, now let me see the output. Okay, this is pretty simple. See, people may use different programming languages like C, Python, even functions to process the data. Let me show what are all functions through a query. Okay, the same way I showed here, it will show the similar kind of record over here. So if you want to drop, you can drop the function with this command, drop function name. Okay, I'm going to drop the table as well. That's it with functions. Let us move to the next topic, that is views. Okay, let me go to views. A view is a virtual table whose data is the result of a stored query, and part of this demo I will show how to create a view, how to drop a view, and the listing of views. Okay, let's move to demo now. Let me close this, go to query tool, open views demo. Okay, before starting my demo, I would like to show one more. No, why exactly we need a view. If you look at this query, which is complex in nature, which will populate the table details, okay, its owner, and which schema that particular table resides, in which table space it is residing, right? In order to know that, every time I need to write this big query. In order to simplify, what I will do, I will create a view like this. Okay, next time onwards I no need to execute that big query. Select star from my view name, right? This is pretty much simple. So that's it. And if you want to see the details of a view, what are all present, right, you can use pg_views. It will show the details over here, and you can use drop view to drop the view. I would like to show one more advantage here. Okay, let us see, for example, okay, this is bigger in nature, that's fine. It has 500,000 records, but I want to restrict the number of records to 10, and I want to show only 2 columns here. Actually I have 3 columns in this particular table. Oh sorry, it's not ID, it's NO. Okay, only 10 rows, and it is populating 3 columns, right? For example, I don't want to show the transaction date, like the end user is especially looking for number and name. Then the best option is like how normally what we'll do, sorry, typo. Okay, so instead of writing this query, what I will do, I will create a view. I will give access to this view, like read-only access. So the end user may feel that, oh, this particular table contains only 2 columns, right? So with this way you can restrict the number of rows or number of columns can be viewed by a user. With this I'm closing my demo on views. Let us move to the next topic, that is triggers. Let me close this. Okay, now the topic is triggers. Trigger is nothing but a function which will get invoked automatically whenever an event like insert, update or delete operation occurs. There are 2 types of triggers in PostgreSQL. One is row level trigger, that means you can define the trigger for each row, and the second one is statement level trigger. The moment when you're processing a set of transactions, you can define in statement level. Okay, part of this demo I'm going to show how to create a trigger, how to drop a trigger, and listing of triggers. Okay, let's move on to demo. Let me go here, go to query tool, open triggers demo. Okay, before starting my demo, I would like to tell one point here. Triggers normally we'll use for validating the data like constraint. It's not necessary always. Second thing, like you can use it for audit purpose. So I'm going to cover the second option, like auditing. How can I audit if there are any changes to my data? Okay, part of this I'm going to create one table. Okay, so this is what my definition of my function. This is going to execute, okay, as and when there is an event, and this function will be called part of my trigger. Okay, let me create a function. Okay, refresh. Okay, and you can't see this as a function, right? But it will appear over here because the type of the function, it is returning trigger. That is why you can see the details over here. Okay, now let me create the trigger. This is my trigger name, and I can define either before or after operation. Okay, and this is what the operation is going to be like: insert, and I'm saying this trigger should execute for each row, and it is calling my function over here. So let me create that. Oh, might be created before. Okay, if you want you can drop and you can create it, but this is the syntax for that. Okay, first let me see is there any records in my audit table. Okay, no records, right? Okay, let me insert one row to my table. This is my actual table. Now let me see the status of my audit table, which will tell what are all data inserted and what time and by whom. Okay, this is where I defined those statement here. Okay, in this way you can capture audit records for delete operation as well as update operations. Okay, there is one more option called instead of, like before, after, instead of. Normally we'll use instead of method for views. Normally views are read-only views, but if you want to update, you can do that with the help of instead of trigger. Okay, now let me list out what are all triggers present in my DBs. Okay, this is the query you need to use: information underscore schema dot triggers. Okay, with this I completed the trigger part. Let me drop the trigger and its associated function and the table. Okay, now let's move on to the next topic, that is sequences. Let me close it. Okay, now let's move to sequences. A sequence is a user-defined object which generates a sequence of integers based on the specification. Part of this demo I will show creation of sequence, dropping of sequence, and listing of sequences which are present in my PostgreSQL database. Now let's move on to demo. Let me go here, click query tool. Let me load my steps over here. Before starting my demo, I would like to tell there is a data type called serial, which also acts as a sequence. Like it acts like sequence, and it generates sequence number from 1, and it will increment by 1. Let me show that. Okay, okay, sorry, I should create the table first. Okay, created. Let me insert. Let me insert again, and this is the content. And for example, I deleted one row from this table. Deleted. Okay, now I can see only one record. Suppose if I want to reinsert, okay, and I inserted, but you can see the output over here. The sequence is 3. There is no 2 here because we don't have any control on that. Okay, so developers or application team sometimes they will intend towards normal sequences instead of serial. So part of this, I'm going to create a sequence here. This is my sequence ID, and I'm saying increment by 2. I will tell why I'm saying increment by 2, and minimum value is going to be 1, maximum is going to be 50, start with 1, and there is an option called cache. That means you can load the sequence numbers in advance into the memory. Okay, and now let me tell this bit increment by 2. Let us assume that I have two data centers where end users can access their application, and for example I have A and B data centers. Whatever the data inserting right in data center A, which is coming to A, that should have a sequence with odd numbers like 1, 3, 5, 7, something like that. And the other data center like B, whatever the data coming in over, it should be 2, 4, 6, something like that. And later I will establish a replication like multi-direction replication to replicate the data. So normally people will use sequences in that scenario. Not only that specific scenario, it's up to application requirement. Okay, part of this, let me create a sequence here. Created. Let me create my demo table. Done. Let me insert this. Let me insert one more. Okay, so similarly what I will do, before that check what is your current value, and the next value is going to be 5. Okay, let me delete one record, select. Okay, so now what I will do, I can reset my current value. You can see what is the current value. Good. Okay, let me execute insert statement. See the data over here. See, so you have complete control right on the records. Okay, let me show what are all sequences present in my DB level. This is the way you need to check. Okay, with this I'm completing my demo. Before that, let me drop demo tables, sequence, okay. With this I'm closing my demo. If you like my today's demo, please like, share and subscribe. Please post your feedback in comment section. I will review and get back to you. Thank you.